Okay, so in this video, we're going to be talking about I2C. So what exactly is I2C? Well, it stands for Inter-Integrated Circuit, and it is a digital communication protocol standard that was created by NXP Semiconductors. So what this does is allows two digital devices to go ahead and talk to each other so we can send and transmit data across this sort of digital communication protocol. So say you have one microcontroller that is doing one specific task. So maybe it's like reading in a sensor value, reading in like an analog signal. And so what you can do is with another microcontroller, you can access the microcontroller data via I2C, and that microcontroller can therefore transfer to something else. So it's pretty beneficial to actually make it so that to increase the scalability of your circuit, because what you can do now is you can enable multiple digital devices to talk to each other and do specific tasks and help to create hierarchies in your circuit. So this is typically used more in the instance of sensors. So typically what you want to have for this sort of layout is you have a microcontroller that's connected to a sensor via I2C, and the sensor will collect data, and then once it collects that data, the microcontroller can read that data out via I2C. So, but what's most important about this, though, is that many different types of semiconductor companies will actually create devices that work on this specific digital communication protocol. So at some point in time, you're going to have to learn exactly how to get a microcontroller to talk to that specific part or device that you bought via I2C. So let's go ahead and talk a little bit of exactly how this all works. So we have two digital lines over here. So these are just two digital pins. One of them is SDA and the other one is SCL. So SDA stands for serial data. So this is a serial data line that is used to transfer data. And right here is SCL, so this is a serial clock. And so what the clock does is it helps to make it so that when the data is being transferred between two devices, it helps to ensure that they are in sync with each other. So this helps to ensure that no bit gets lost, and every bit that gets transferred gets interpreted correctly at the same speed as it's sent out. So those are the two lines that you need for I2C. Nothing more, nothing less. With that, you can actually see that there are two resistors over here. So one resistor is connected to SDA and the other one is connected to SCL, and it's connected to some higher voltage. So these are pull-up resistors. And what they do is they help to make it so that the digital lines are set to, by default, a higher voltage. And typically you want to have it so this is like typically 4.7K or between 10K are typical resistor values that you have for this. 4.7K is kind of the go-to, so that's just something to keep in mind. So VDD is typically a higher voltage, the digital voltage in particular, so the logic voltage that we have. So in our case, this is going to be 3.3 volts, but it's going to ultimately depend on what kind of microcontroller you use. So if your microcontroller runs on 5 volts, it's going to be 5 volts instead. But in our case, again, we're running on 3.3 volts, so we're going to use 3.3 volts. All right. So as you can see, I've ignored these blocks for a good reason, because it's going to take a while to explain how this all works. So we're going to do that in the next video.